All right, so I think this is recording. Let's take a look here at number 8. We have two rational expressions. We want to multiply them together. We want to get a single rational expression in lowest terms. We also want to state our restrictions. Restrictions in the arithmetic in this case come from the fact that we have variables in a denominator, and we want to make sure that we never have division by 0, that the denominators are never equal to 0. Let's start out by writing these two fractions as a single fraction by multiplying the two numerators together and multiplying the two denominators together. So we have 45x squared times this trinomial x squared minus 5x minus 36. And let's multiply these two binomials together. We need to put parentheses around each one. All right, so let's look and see what we have here. Well, we're working towards it, but we don't have it in completely factored form. It's not easy right now to see what factors cancel, and it's not easy to see all of our restrictions. So let's look at this 3x cubed plus 12x squared and see if we can't factor it further, and then we'll also factor that trinomial that's in the numerator. Let's come off to the side and look at 3x cubed. I'm going to write 3x cubed as 3x squared times x. And I'm going to rewrite 12x squared as 3x squared times 4, because 3 times 4 is 12. And now it's a little more obvious that 3x squared is common to both terms. And I have that times this binomial x plus 4. In my numerator, that trinomial, let's use our x method. Write an x off to the side. I like to write it off to the side rather than over the middle, because sometimes when I draw my x through my minus sign, I later look at it and think it's addition. So I like to write it off to the side myself. I have minus 5x, and the first times the last is negative 36x squared. So I need two values that multiply together to give me the top expression, but add to give me the bottom. So if I have a negative 9x and a positive 4x, that product is negative 36x squared, and the sum is negative 5x. So we're good. When you have a leading coefficient of 1, you can take a shortcut. You don't have to make a table. You can come over and say x minus 9 times x plus 4. And that trinomial factors to a product here of these two binomials. So let's come over back to our fraction. We've got 45x squared. We said this trinomial in the numerator, we just factored it to x minus 9 times x plus 4. In the denominator, we have an x minus 9. And this binomial, we factored it. Excuse me. I tried not to sneeze in the microphone. So now that denominator, now the whole thing, with everything being in factored form, it's a lot easier to see a few things, starting with our restrictions. We can't have a 0 in the denominator, so x can't be 9 because 9 minus 9 would give us 0. You have just a single x here, x squared. If x is equal to 0, then 0 squared is 0, and 0 times anything is 0. So we want to prevent x from being 0. This x plus 4, if x is negative 4 plus 4 is 0. We want to prevent that. All right, so let's look and see here. The x minus 9 divided by x minus 9, that's 1. The x plus 4 and x plus 4. And this x squared and this x squared, they cancel. All right, so we're almost done here. In the numerator, we have 45. In the denominator, we have a factor of 3. And before we say that's our final answer, you can check on your calculator, but 45 divided by 3 is 15. So I don't think there's very many of us that looked at this complicated expression that we started with, this fraction times this fraction, and said, oh, that's obvious, that's 15, you know, provided that x is not equal to 9, 0, or -4. There's no way I would have been able to do it like that. I have to do it in steps. I have to break things down. I have to show my work and just approach it step by step. All right. I hope that helps, and I'll talk to you later. Bye.